Hello everyone, welcome to Projects with Gaurang, and today we are going to do another chicken farm optimization project, which is cluster head selection. In IoT or in any other wireless network, one of the most important tasks is cluster head selection. Why? Because most of the times we will be using tree topology. Here in question it is also mentioned, but in general, if you look for practical point of view, tree topology is the most used topology in terms of like IoT applications or wireless sensor node applications. So for tree, you need a root. That root is also called a cluster head. It's just a terminology difference because like tree is always growing like down. So just not to confuse it. That's why cluster head selection is one of the most important tasks. Any node you can select as cluster based on your requirement. It is not like, okay, you have to make this node cluster head, but yeah, cluster head should be like the node which has most resources. Like it should have more memory than other nodes. It should have some more power or some better recharge capacity than other nodes, because most all of the nodes in that cluster are dependent on that cluster head with the for the communication from the base station. If the cluster head fails, all the nodes in the cluster are like isolated. They will not be able to send data to the base station, and if base station does not receive the data, then we don't have the data that nodes are collecting. So you should also make sure that the node you are selecting as the cluster head is the most reliable node, because a cluster covers an area, and if the cluster head fails, all of the nodes in that area are practically useless. So keep that in mind too. Now let's start coding. First we will import all the necessary libraries. So import numpy as np, import matplotlib, plotlib.py, plot as plt. Now we will define all the constants. So here are the constant: number of nodes, number of clusters, dimensions. Dimensions just that we are spreading the nodes in two-dimensional space. Solar panel recharge, average consumption, extra communication consumption. You can remove some of the parameters, like if you don't want that, okay, node should not be rechargeable, so you can remove this solar panel recharge, or if you want to use some different value, you can do that. Also, sometimes extra communication energy is not considered. It is considered in this average consumption, so you can do whatever you like. I'm doing it this way. Now we will make the function for defining the tree topology. So here is the function generate tree topology. What it will do is it will generate a balanced tree. 1 minute. Yeah. It will generate a balanced tree with specified number of clusters, whichever you define. Here we have defined 5 clusters, so it will make kind of 5 trees, you can say. So it will randomly assign parent indices, and then with those random indices, our tree topology will be made. Now we will make the objective function. So here is the objective function. It is a simple objective function. I am optimizing this total energy consumption by the whole network, not by one node. It is of the whole network. So here the base station position is defined. I am taking origin as the base station position. You can change that. Then for I in range num nodes, for every node, I'm checking what cluster is assigned to it, what's the distance to the cluster head, node energy consumption, because average it will always consume. If the node communicates to the parent, then we have to add extra energy, and node energy also we have to subtract the solar panel recharge, because this is the energy that is not consumed. It is given to the node, so we have to minus it. Then we will get the node energy consumption by the maximum of 0, and node energy consumption, it's just a check to ensure that node energy consumption is not negative. Then total energy consumption is added to the node energy consumption, and total energy consumption is returned after the for loop. Now we will write the chicken sum optimization function. So here is the chicken sum optimization function. Now what is happening in this? First we got the parent indices by the generate tree topology function, and then the clusters by the randant. Then we randomly assign the node positions, the cluster heads, chicken velocity, everything is randomly assigned. Then best cluster heads is created. We are assuming that the cluster heads which we just here created randomly is for now the best cluster head position. It will change and it will improve. Then best fitness is from the objective function which we defined here, this objective function. So we pass the node position, best cluster heads, parent indices, and clusters. So we now are getting fitness values. Best fitness, you can say, is the least energy consumed by the network, and fitness value is just a random value which will be generated through these random cluster heads, node positions, and chicken velocities. It will be improved. So what we do is, when fitness value arrives to us here, we update these chicken velocity and every randomly generated parameter such that they will give best better result in next iteration. And here that's why we are doing so many iterations. Then we checked that if the fitness value is less than best fitness, then we did something and we updated chicken velocity. You can see we still have some randomness which is needed actually for this algorithm to work. And then we checked the conversions. Here we updated the cluster heads. Simple, we got the distance and clusters. Now this is one of the most important parts I added. I wanted to make sure that no cluster is empty, or you can say there is only cluster head present in the cluster. It's I don't want that case. So what I did, I checked that for every cluster at least there should be one node. If it is not, then this function will be re-executed, and this message will show up. So we will know that how many times you can say we have to rerun the algorithm to get it. But we will not print the result which is executed in the first try. We will only get the result which we will get after this check. So you can remove this check, but I will suggest that please have this check, because if a cluster has zero nodes or only the cluster head node, it is not a good thing because it is of no use. And secondly, if you have only one node, why make cluster head, or why assign it a different cluster? It can be easily merged with a existing cluster, so it makes no sense. That's why I checked it. Here we are returning the best cluster head, best fitness, node position, and clusters. So now we will make the last function, which is plotting function. So here is the plotting function. Here you can see what I have done is I have first did the fixed size just to set the screen. Then I have selected colors. These are random colors and depends on how many number of clusters we got. Here you can like decide. I have decided 5. In the further code you can decide 10, 15, anything. And then we have plotted the clusters. Here you can see I'm using scatter plot. You can use again any other plot, but I will prefer scatter plot because it gives you can say a physical representation that okay, the nodes will be scattered in an area, so it gives that effect. So now let's use those functions which we just made. So here is the code. Here I have selected number of iterations as 100. Again, you can change it. Then I have got the best cluster heads, fitness, node position, and cluster through the our CSO function, and then the plot. So now let's run it. Let me go above and start the. So here you can see rerunning algorithm due to cluster issues. The check I have selected here. So it is removing any case where any one of the cluster is empty. So it can happen multiple times. So here you can see the colors are different. So base station is fixed because I defined the position of the base station. So here you might see this is a very good example. Here you can see this cluster head has this cluster. You can see that. So what happened is that this can be made a cluster head of this cluster, and this, which is actually the cluster head of this cluster, this purple one, could be made of this one. So it is a further optimization that you can apply. So green one is you can say a good case because it has no, like, you can say color inversion, or the cluster head is closer to the cluster nodes. Similarly, this with a green, this sea green and this yellow, their positions can be interchanged. So this you can think, or you can, like, make the code do that, or you can do it yourself. So we have just selected 5 clusters. It is easy for us. In many cases, when you have like very big networks, you can say you have 100 cluster head, it will be very difficult. So this is one improvement you can apply. Like, you can define it here. Let me show you here. So you can define this check here, or what you can also do is you can frame this logic even better so that this case never arises. So this is some of the improvements you can do, and if you do this improvement, do comment in the comment section. I would love to see your code. So here is the code and here is the output. So thank you very much for watching the video. If you like this video, do subscribe to my channel, and also like this video. Do tell what more projects you want to see, and I will try to build them and I will share with you. So thank you very much for watching the video. Thank you.